Hey everybody, this is a video on energy line graphs on roller coasters without friction present. Alright, so we're going to analyze this roller coaster right here, where the roller coaster carts, they start at position A at rest, so they're not moving to start with, and position A is also the highest point on the roller coaster. And what I've done along the way is mark how far they go on the track, basically the track position, every 10 meters until they get 80 meters down the track. These numbers are not the height above the ground, okay? So you can't plug them into the GPE formula and solve for GPE. That's not the point of them. It's just showing how far they go along the track, all right, until they get to the end. So we're going to look at position A, where they start at rest at the highest point, position B at the lowest point, where they get to ground level, where the height is 0, and position C, which isn't as tall as position A, but they do gain some height back, right? And we want to put 3 lines on our energy line graph, all right? The point of the energy line graph is to show as they go further on the track to the right as the track position increases. The track position is on the x-axis, so when you go to the right, that means they're just getting further along the track. How does the energy on the y-axis, how does that change? And we're going to look at 3 different kinds of energy. All right, we're going to look at, well, really 2 different kinds, and then the sum of those 2 kinds. All right, we're going to look at GPE, which is going to be in purple. All right, so use a color of your choice for that. We're going to look at kinetic energy. I'm going to use green for that. Use another color, different color of your choice, and choose a third color to represent the total energy, which is the sum of the GPE and the KE. When you add those 2 together, you get the total energy, okay? So let's start with total energy, okay? And the total energy line with no friction is going to look like a flat line for the total energy. This is because let's write this down underneath the coaster here. When no friction is present, the total energy, is that going up or down? Well, neither. It's stays constant. All right. So because of the law of conservation of energy, you cannot get extra energy or lose energy. All right, your total energy, whatever number that is, it stays constant at that number. It never changes. Friction would be something that could lower the total energy, but we're doing a graph with no friction right now. Okay, so let's look at that should be always the line you start with. If it is no friction, you could just make it a flat line. The second line you should always look at is GPE, because you could just base it off how tall each position is above the ground. I know I didn't give you an exact number for height, but you could see that position A is the highest, okay? So position A, we're going to start it right where, for GPE, because it's the highest up, it has the most GPE, and as it goes from, I'm going to say this is position A right here, all right, at track position of 0 meters, all right? And then it's going to go along, eventually it's going to get to about position B, where it's the lowest. So at position B, it's the lowest. So the GPE lowers because it goes downhill from position A to position B, all right? All right, kind of like that. So draw that line. And where is position B? What track position is that? Well, it's somewhere between 40 and 50, so I'll call it 45 meters, and I'll write that, and I'll mark that right here on my graph too, 45 meters for position B, all right? And after the car gets past position B, it begins to gain height, or gain GPE at that point, up to position C, okay? Now position C, that's somewhere between 70 and 80, so I'll call it 75 meters, all right? So it goes to 45 and then gains height up to 75 meters of track position. And then at that point, does it have as much GPE as what it started with? Well, if I look over, position C is still a little lower than the starting position. So position C doesn't gain exactly as much height as it started with, or is it exactly as much GPE as what it started with. Alright, so position C, yeah, the GPE goes back up, but not all the way to what it had at position A. Alright, so there's your line for GP. It starts with a lot. In position B, it has very little, 0 in fact. And at position C, 75 meters down the track, it has much more, but not quite as much as it started with at position A. Now the last line in this position is the kinetic energy. And we should pay attention to this. It starts at rest. So how much kinetic energy does it have to start with? At the beginning, it has 0 kinetic energy because it starts at rest. And we can imagine as it goes downhill, it's going to be speeding up. Alright, so it's going to be gaining kinetic energy. Alright, so as the cart loses GPE, it's also gaining kinetic energy until, where does it have the most kinetic energy? Right here, position B. Alright, where it has the least amount of GPE, that's where it has the most kinetic energy. Okay, in fact, it goes all the way up to the total energy line because it has no GPE at that point, so all of its energy right here is kinetic. So this line should actually go up and meet the total energy line right there. Once it passes position B, it begins to go uphill, which means it's slowing down a little bit. Alright, so at that point, it has to lose kinetic energy. Alright, kind of like that until it gets to position C. Alright, and that's where it's going to, after position C, it's going to go back downhill. So we can imagine it does speed up again a little bit at that point and gain more kinetic energy. So if you're going downhill, your kinetic energy line is going up because you're gaining speed. But once you pass position B, you go uphill and your line begins to lower a little bit, all right, for kinetic energy. All right, so the idea is that when you're gaining kinetic, you could see that you're losing GPE, and when you're gaining GPE, you could also see that you're losing kinetic. All right, and you're going to see that with these energy line graphs.